If I drop two objects of different mass, they hit the ground at the same time, at least if air resistance is not a factor. What about rolling? If I roll two objects of different mass, should they take the same amount of time to roll the same distance? Well, there's a bit of a catch. Let me show you. I'm going to start with two objects that have the same shape. These are both cylinders, and this one is much heavier than this piece here that looks like a hockey puck. But I'm going to roll them down this slide. Let me start below where the Velcro is. I'm going to release them at the same time, and we can see whether or not they roll down at the same rate. That's pretty close. Let's take two other objects that are the same shape. Here I have two hoops, and all of the mass is one radius away from the center of the object. When I release these two, again, they roll at the same rate. If I take two spheres like this looks like a miniature billiard ball, and this is a golf ball, and I release them. Okay, that might have cheated a little bit because we don't know whether the material inside the golf ball is uniformly distributed in mass. Likely it's not. Okay, now here's where things get interesting. What happens if I take two shapes that are different and I roll them down this highway here? Let's see what happens. The cylinder is clearly winning. Let's trade out this cylinder for another cylinder and try it again. It was the cylinder that won, right? Oh, that one was even clearer. So different shapes will roll differently. So that means we can't rely just on the mass. We have to introduce another quantity. And that quantity is called the moment of inertia, or the rotational inertia. We use the capital I to stand for it, and it is a measure of how hard it is to get an object to rotate.